In this video, I will discuss a bit more Newton's second law, and I will show you how you can go from the net force to finding the change in momentum. Now, before I start talking about Newton's second law, I want to go back and remind you a few things about position, velocity, and acceleration. We saw that whenever you have the position time graph, if you wanted to get the velocity time graph, what we always did was to find the slope. So from position to velocity, we had to find the slope. And this is also shown with the equation right here. The slope of position, the rate of change of x as a function of time, will give you the velocity. Now, acceleration is defined in a similar way. The rate of change of velocity with respect to time will give you acceleration. Graphically, this is the slope. So from velocity to find the acceleration on a graph, you have to take the slope. Now, if you remember, if we had the acceleration and we wanted to find velocity, so if we wanted to go this way, we were always looking at the area under the graph. So in this case, we were looking at the area under the graph. Now, whenever we had velocity and we wanted to go to position, again, we did the same thing. We looked at the area under the graph. Now, by Newton's second law, the net force is equal to the rate of change of momentum with respect to time. So if you have momentum and you want to find the net force, you're looking at how fast momentum is changing. So on a graph, we are looking at the slope of momentum. Now, you can see here that because the relationship between momentum and the net force is the same as the relationship between x and velocity, if you have the force time graph and you want to find momentum or the change in momentum, then you have to look at the area under the graph. So if I have the force versus time graph, let's say, for example, I have a graph that looks like this. This is the force. This is the force versus time graph, and we want to calculate the change in momentum. Then we have to look at the area under the graph. If for example, let's say you want to find, let's say this is 0, this is t1, and this right here, this is t2. If you have to calculate the change in momentum in the x direction, then you really have to calculate this area over here. So this is the area that you will have to calculate if you want to find delta px. So this area will give you the change in momentum in the x direction. Now, don't forget, whenever we say change in momentum, we are referring to the final momentum minus the initial momentum. And since momentum is approximately equal to the mass times velocity, you may be able to find velocity if you have the initial velocity or the final velocity and the mass and so on. But the starting point is always looking at the area under the force time graph. And the last thing that you need to remember is that we have a special name for the change in momentum. We call this quantity the impulse. So if you ever need to calculate impulse, then you need to find the change in momentum, or if you have the force versus time graph, to find the impulse, you need to find the area under the force time graph.